We take it for granted today that hormones and other ligands have receptors. But this was not the case till the groundbreaking work of my next interview subject, Dr. Jesse Roth. Welcome to the Journal of Clinical Investigation series, Conversations with Giants in Medicine. I'm Ushma Neal. Indeed, Roth of the Feinstein Institutes for Medical Research is best known for his research on cell surface membrane receptors. His studies on the receptor for insulin, growth hormone, and ACTH in the early 70s became the model for many others who followed him. Thank you so much for joining me today, Jesse.
Thank you for having me.
Can you start by telling us a little bit about your parents and your upbringing, though it'll be very apparent to many when they hear your voice that you grew up in New York?
I have New York notched in my tongue, so I did grow up in New York. I was lucky. I was born at the depths of the Depression, so by the time I got to school, we were smaller classes. But so I grew up in New York in a middle-class background. My mother was an immigrant from Europe. My father's parents immigrated from Europe. He was orphaned when he was 12, and so it was a miracle that he supported the family and got us. So we were very lucky kids.
Did you grow up around doctors and scientists? Were you a good student? Where did the interest come from?
It's interesting. At the time we were growing up, science was just the hottest thing. So it was new. The other stuff that you learned, the arithmetic, spelling, was left over from 100 years ago, 1,000 years ago, whereas the science was all brand new. And so 3 or 4 of us in each class were just turned on by science from the beginning. Did those silly experiments, adding vinegar to bicarbonate soda and things, small explosions. And we were also lucky. The school I went to was a small school. In order to do science, they had to hire a science teacher to come in from the outside for an hour or 2 a week. That let them pick the best public school teachers to come and do it. And these were, again, enthusiastic, energetic people who in other times might have been scientists themselves, but instead were science teachers. So it was just an atmosphere of excitement about science. That was the cutting edge.
So you ended up at Columbia University for undergrad, yes?
Yeah, I was lucky again there. It was a fun place to be. We'll tell parents nowadays the tuition was $600 a year. And I remember I got to New York. In those days, it was, you sat for New York State scholarship. You sat and did a 6-hour exam, and based on the score, they gave you one or not. So the state paid $350 out of the $600. And the same thing happened when I went to medical school. They had, for New York State medical scholarships, you sat down, you did a multiple choice exam. If you came out above the cut line, you got $750. And at that time, medical school tuition was around $1,000 a year. So again, when the kids nowadays or the parents look at what we paid, it's a miracle.
So you were in the first medical school class at Albert Einstein, correct? Yeah. Why did you take a chance on a completely new medical school?
That's a good question. I can answer it quickly. In those days, if you were, the prejudices in the medical schools were tough. So if you were Jewish and you were from New York, you had a tough time getting into medical school. So I didn't get into a fancy medical school. I got into one of the good, middle of the road medical schools. There was downstate, there was SUNY upstate, and so on. And Einstein was just beginning. I had a cousin who was a physician, whom I liked very much, and I got along well. He was very impressed with the faculty that Einstein was putting together. So he was cheering it on as we go. Even though when we went to get interviewed, the only building they had was a small one-family house in the Bronx. So you needed to have imagination and courage. The other thing was my parents, I came from an Orthodox Jewish family, and so my parents said, Jesse, if the Orthodox Jewish community is putting up a medical school, of all the people that should take a chance on them, I guess we ought to.
Right.
And so I went there, and it was such a good choice. And in fact, now at Feinstein, they just started a new medical school when I was there. And I was trying to convince the good young people who were coming that there's such an excitement of a new medical school. And in fact, I called 4 other colleagues of mine who each had started in the first class of a new medical school. And with one voice, they agreed, it's the thrill of a lifetime, nothing like it. And I would even say, it's a great idea even today to scout the medical school if it looks like it's going to go.
So how then, after a life in New York City, you grew up here, went to Columbia, stayed here for medical school, how did you decide on going to St. Louis and Washington University for your residency?
Okay. It's funny because in those days, you can't recognize it now, but academic medicine in the United States was really in the upper quadrant of the map. It didn't go south of the Mason-Dixon line. It didn't go past the Mississippi. And so most of the guys from New York did want to stay in New York or around. My professors of medicine convinced us to shop more broadly. So my classmates and I actually went out and looked at, and they were the ones who pointed out that Washington University St. Louis at that time was really in one of the top echelons. And again, they called ahead. There was no match, so there was much more of the horse trading. And so, Jesse, where do you want to go? Oh, I thought St. Louis was terrific. Good. They got on the phone, you know, and those kind of arrangements were made. My roommate from medical school went to Yale. One of my other classmates was at University of Virginia. So it was, they really, especially because it was a first class, wanted to make sure that we were placed in very exciting places.
Was it during that time you fixed on endocrinology as the sort of thing that was fascinating to you, or where did that occur?
Okay. That occurred pretty early, and actually it well occurred in college because endocrinology was just starting to explode. And so even though the college courses weren't rich in it, when you went to the library, you got excited by it. And it turned out that in St. Louis, they had a very rich endocrine group. In those days in the Department of Medicine, if they had one person in each specialty, that was enough. In endocrinology, they really had a fistful. And they had people who were very well known, very talented, very good teachers. And it was fun. If you were an intern or resident at St. Louis, you put in a consult before noon. The endocrine group would see the patient by mid-afternoon, and they'd come and talk to you. And so it was really a tutorial through internship and residency in endocrinology.
All while you were growing up and going to college and medical school, did you have in mind that you would do scientific research, or were you going to be a clinician?
I think almost all of us grew up as an image of ourselves with a little black bag, walking up 4 flights of steps to see some poor kid or some old lady. And so we had been, but also we had a delusion of how much you can do. So we were going to do clinical work for 50% of our time, and teaching for 50%, and experimental work for 50%. We had this kind of, so I think we just thought we were going to do everything.
So then what put you on a track towards doing research?
The group in St. Louis were both very good clinicians and very good researchers. And so we were just turned on by what it, and in fact, again, they helped us find the places. It was also funny because I was all set to go to one place. I was on kind of the waiting list, and they told me, well, our deadline is November 1st, and we'll let you know right after that, but meanwhile, you have the inside track. Just before November 1st, one of their guys took the spot, and so I was left to know. So my professor of medicine from New York was the one who said, well, Jesse, what are you doing next? Well, I don't know. I said, well, you know, it's getting late. And he was the one who fixed me up with Burson and Yalow. He knew they were doing very exciting cutting-edge research. A bunch of cognoscenti knew it, but the world of science didn't realize it. And he was the one who made in fact, I wrote to Burson Yalow, and he sent me back a very hesitating letter until he got the letter from my professor. And he says, forget the first letter, come. And that's how we got started.
That's right. They were working at the Bronx VA.
Veterans Hospital.
Yeah.
So it was a known place, but it wasn't Harvard, Thorndike, Yale. It was.
So they had already started to crack the radioimmunoassay by the time you got there.
They actually presented their radioimmunoassay a year before, and my professor of medicine, some of the other people recognized what a landmark this was. And also, they were a small group. What was nice about them is they weren't traveling. They were home, they were at the bench. So it was, from the point of view of the people who understood how science and teaching is done, they saw that kind of hands-on right there. We also were lucky. Burson and Yalow each took their families to Europe for the first time they ever went to Europe as we started our fellowship. So we came there without, so they told us, well, why don't you take your vacation while we're on vacation? But we went to work in the lab, and we were lucky because we got used to the lab before they came. We read all the papers they had written. When they came back, they thought we were geniuses because they never had such smart students. So they treated us like, we were the children of the Pharaoh, and so we had a wonderful time right from the beginning.
So your project while you were there was working on an RIA for growth hormone, correct?
Exactly. The insulin one clearly set the pace for everybody. Growth hormone was slow in emerging among the hormones. It turned out that the animal growth hormones were different from human growth hormones, unlike almost all the other peptide hormones. So it set the field back several years. So when we came, human growth hormone was really just becoming available. It was a big puzzle for multiple people. It was a spotlighted project, and we got started on it.
How did you end up as a clinical associate at the NIH?
Okay. In those days, the Vietnam War was on. In fact, when I first turned 18, the Korean War was on, and they were drafting people. And for whatever reason, I didn't trust the federal government's commitments. So I kept avoiding signing up for anything. Many of my friends signed up for this or that, and many of them were disappointed that so I just, then I went down to NIH the year before to try to look for a job, because if you went to NIH or CDC or FDA, that was considered full government job, that's okay. I went down to NIH, I looked at the endocrine jobs and I didn't get one. One of my good colleagues there was ahead of me and said, Jesse, there are a lot of good jobs at NIH, there are a lot of bad jobs at NIH. Don't take a bad job. So I risked that year not having a deferment, and I was lucky. I didn't get drafted, and the next year, the plum job that I wanted did. And again, it came because the Burson called the guy at the NIH, says, Ed, I got this kid for you. And so I both like the job in St. Louis and the job at NIH, I was kind of hand sent by my boss to.
Well, that's fantastic. So it must have been quite a heady time at the NIH with the sheer amount of talent that was there with you at the same time.
The group leaders at NIH were terrific. And then they sent a large number of young people anxious to go. The other thing that was terrific about the NIH was there were really no walls. So it's not like the universities or the hospitals where they had, this is the one group, this is another group, and they didn't talk much to each other. This was just kind of one big open house. You lived all in one big building, Building 10, was a big monster, red brick building. You ate all in the same cafeteria, you made night call in the same place. You talked about your science, you asked them about their science. So it was just a grand market of ideas. Science was also much easier in those days. You could do a competitive piece of work in a year. You'd get the help you needed. It was recognized. The science got more complicated, so had we come 10 years later, we never would have skyrocketed that way. It was, the time was right and the mix was right. And we were in heaven.
Yeah, so you rose from being lowly clinical associate all the way up to being the scientific director of the NIDDK and with the rank of assistant surgeon general. So what was that time like for you within the NIH, and can you talk a little bit about what you felt like you were able to accomplish during that time?
I think that the advantage we had was we had a lot of excellent young people coming to work with us. The space was very crowded, but the budgets were relatively, you could get resources, you could get help, you could go to anybody and talk to them to do. So anything you wanted, you just got on the phone, walked upstairs, down the hall. You could meet people, and even at corner, I used to take them to one spot. This spot here, there was a Nobel Prize winner 50 feet down this way. There was a Nobel Prize winner one flight upstairs. There was another one over there. So it was a crowd of very excited, very hardworking people. They also liked each other. There wasn't a lot of bickering. There wasn't a lot of petty nonsense that sometimes poisons an environment. We were in heaven.
And this was also the time when you came up with your extremely controversial ideas that hormones could have receptors.
Yeah. That was really fun. Ira Paston was my partner at the time. He was just finishing up one lab. I was coming from Bursa's lab. And the big boss of the institute came, and there's a tendency in those days for you, whatever success you had, to just continue with the rest of your life. So when I came to the NIH, my boss there, Ed Rawls, said, well, what do you do? I said, well, the thing to do is we'll just continue doing the growth hormone for the rest of my life. He says, yes, you could do that, but it's an exciting time. This is an exciting place. Why don't you see what else you might want to do? So while I started on the growth hormone to keep that as to pay for the lunch and pay for the month's rent, Paston and I decided, well, just like the antibody can see insulin, why can't we figure out what the cell sees when insulin is there? How does the cell know insulin is there? And that's what we started on in 1963. It took us much longer than we thought. Thankfully, we each had little other projects along to pay for the, and in fact, I was teasing when I met my wife in 1968, and I told her, well, I get invited to the meetings on insulin, but we're really working on the receptors. That was where we were headed. We knew it took much longer than we thought, but fortunately, the momentum of the other stuff kept us alive intellectually.
So how difficult was it for the field to accept the fact that insulin could have a receptor as opposed to, generating second messengers at the plasma membrane?
Yeah. It took time, like I warn the young people, you get a great idea, it'll take much longer to get it done, and then even if you get it done, the people out there won't believe it. So you really have to be patient. I remember presenting some of this work to several good places, and the audience kind of looked at you, why would you be wanting to do that? So there's the time of getting the good idea, then formulating into experiments, get those to work, present them, and then the time it takes for the scientific audience to say, oh yeah.
I mean, now we take it so much for granted that there's a receptor and that's what mediates the signaling. I mean, it's kind of mind-boggling that there ever wasn't that idea. All right. I spoke to some of your colleagues before we had this interview.
Okay.
One of who said, Jesse Roth was a visionary and he was before his time, and he was talking about using yeast and worms to understand insulin signaling and evolutionary conservation, even to the point of looking at whether or not there was insulin signaling in spinach.
Okay.
So you were using these kinds of methods way before they were popular. What set you down that path?
What set us down that path? And it's very funny because as the receptors were just starting, my friend Paston was looking for hormones in a bacteria in Clostridia, and I started to look for insulin in E. coli. We had worked it out. In those days, it was thought that the hormones, the glands that made the hormones were only in vertebrates, and therefore the logical assumption of the community was that the hormones were restricted to the vertebrates. But there was no real reason they were that way, so we just started to track it down. We did flies first, fly heads. Oh, they got insulin. Fly bodies, ooh, worms. Wow, I bet you the protozoa won't. No, they did. So we didn't have any genius then. We went kind of one by another. And then when we published on insulin-related material in bacteria in the early 80s. And it was just, then we went to the bacteria guys and said, well, tell us about the microbes. And it turned out in those days the microbes were hardly known. The microbiome was a black box, it was hidden. And it really wasn't until 20 years later that that field exploded, and then working on the bacteria became permissible. So in fact, the major theme we're working on now really is hormones in microbes. We published a major paper on it, and it's a major theme. So it looks like the hormones that are sitting in your intestine and my intestine are making hormone-like materials that are taking good care of us.
Yeah. You always make an interesting point about prophets versus priests in science.
I'm laughing too because the priests eat, the prophets sometimes get killed. You need to be lucky that you're in a place or in a situation where you can take on projects that are exciting but risky, and you can follow them through and do other things that will support the program. That was one of the advantages of the NIH. We didn't have to renew a grant every 10 minutes. You had budgets. If the boss appreciated how good the work was, you didn't have to worry what the slowpokes thought about it. You could carry it.
Do you think this kind of research and this approach and the way that the golden era of the NIH was, do you think that that still exists today within the NIH?
NIH has less of it now. Part of it is the number of young people that are going into research has diminished. The number of physicians has diminished. So now the domination of a good biomedical community has mixes of PhDs and MDs. Now the number of MDs is diminishing. The other thing that's come up is the expense of college, the length of training. So the young physicians come out, they're already old, they're married, they have families, they have debt to pay. So the problem now is that the society of research has just kind of grown without any planning. And if you look at it, you can see that this casual growth hasn't been well thought out, and it's in a way, many ways self-defeating.
You speak about your time at NIH with such reverence. Why did you leave to go to Johns Hopkins? And then why did you pivot also towards gerontology at that time?
Okay. I was at NIH for 26 years. By that time, I was entitled to a pension and my 3 children were approaching college age. So the NIH at that time wouldn't let you take your pension and switch into another path and do it. So if I had stayed, I was worried that my kids would wind up with big college debts. And I thought that was such a burden. I had gone through college with no debt. So I decided, well, let me see. And so the Hopkins job, so I looked around, and the Hopkins job was a very nice job. They had 2 jobs open. One was in endocrinology, the other was in aging. The advantage of the aging job is the National Institute on Aging had a very, very good program in aging research in Baltimore, adjacent to the Hopkins at the same time. So it allowed me to, as I was being recruited, the aging job was also had a very rich endocrine group to it, and geriatrics and aging, the endocrinology was growing. So the move on paper looks big, but in reality was very small.
Well, so you were there for 9 years?
Yes.
And you then decided to become the president and CEO of the Picower Institute back here in New York.
Yeah.
So was that partly a desire to return to New York or the opportunity for a leadership position?
No, it was really an opportunity for a leadership position. And I was just turning 65, and at that point a lot of the universities want to move you along a little bit. So this was a new opportunity. The Picower Institute had good young people. They were excited about it, and they wanted somebody. I had a very good record of helping young people develop, so I fit their their job. I was there for about a year, and I think they were getting tired of that institute, the pick hours. And so I was lucky, as I was going to go back to Hopkins, the medical center that I was at, that the pick hour was at, they came to me and said, Jesse, we want you to stay. And they offered me several choices of jobs there, and the one as the head, the geriatrician in chief of the medical system and part of the research. It was at that time they decided they were going to go major league, have a medical school, have cutting edge research, and so they were happy, and I was happy. It was an exciting new place. They were very smart in terms of how they organized things, and they've prospered greatly. And so it was, again, exciting at a late stage in my career to be involved in an embryonic, exploding medical center. And so far they've been very, very prophetic in which way to go. They're probably the largest hospital system in New York now. The medical school has succeeded well. They have MD, PhD programs. The young people have been excited to come, so.
So your trainees over time have included Nobel Prize winners, National Academy members, the who's who of the metabolism field with Bob Lefkowitz, Ron Kahn, Jeff Flyer. We could keep going, especially on the international stage. So what was your approach to mentoring them?
I think that we were lucky. We got very good people. And our job is to convince them that if they work hard, they'll have every chance to succeed. And that if they want to they're going to have to shoot themselves in the foot once or twice if they want to fail. I think it was that kind of attention to tutoring. We treated them like they were Caesar's children, and I think that helped.
So Yellow was notoriously fiery. Yeah. What was that relationship like, and what kind of lessons in mentorship do you think you adopted and or didn't adopt from that experience?
Okay. I think that when she was with Burson, when he was still alive, I think he tempered her, I think that, so I was at one point I was her favorite, and my family, I was invited to her daughter's wedding, and so was my wife, but at every time we made a new advance, she would challenge it, and I'd have to point out to her why it wasn't wrong. And I think it was an overconfidence on her part of how the past is correct forever, as opposed to the new stuff now modifying what went before. So I think that she was just much too easily fixed in ideas that had come before, and as opposed to, wow, it's really new. And
what do you see as the next frontier in the field of metabolism?
Excellent question, and I would have to say that none of us ever have the we're always shocked and surprised. But I think that the complexities of the endocrine system will be helped a lot by our ability to handle complex data. So that we used to do, you give them glucose, measure insulin, but the idea that all the other systems are involved, we'll be able to handle it. The other thing we're learning is that, and that's one of the difficult things in endocrinology, is a hormone acts and the target cell responds. But sometimes what happens when the hormone acts, it not only acts immediately, but now changes the developmental program of the cell. So that when you come back a second time, you're not dealing with a cell that was exactly was last time. I think we'll be able to handle that kind of complex data. And that's one of the things I think a lot of us fail to recognize, is that we are transforming the cells, sometimes long-term, sometimes permanently, and we'll start to appreciate that.
What do you dream about as having been a completely alternate career than the one that you chose?
Wow, that's a hard question. It's just funny because over time I've become increasingly convinced that this was the right path. What else could I have done? I could see teaching. I like teaching. I work at it.
Well, thank you so much for sharing a little bit more of your story with me today, Jesse. I really appreciated hearing about you.
It was a great pleasure to see you again and join you in a joint venture.
All right.